Today we will start Chapter 7, Rational Expressions. Section 1, Simplifying Rational Expressions and Rational Functions. Rational expression can be written in the form p divided by q, where p and q are both polynomials and q is not equal to 0. Examples of rational expressions. Here are 3 examples. You have a trinomial over a binomial, or a binomial over a trinomial, or a monomial over another monomial. They're all examples of rational expressions. To evaluate a rational expression for a particular value, you substitute the replacement value into the rational expression and simplify the result. For example, evaluate the following expression for y equals -2. You substitute -2 into the y and you solve. In the previous example, what would happen if you tried to evaluate the rational expression for y equals 5? You would have a denominator equal to 0. If your denominator is equal to 0, the expression is undefined. Find any real number that makes the following rational expression undefined. For an example like this, you set the denominator equal to 0 and you solve for x. Here, you're just concerned with the denominator and just disregard the numerator for this type of example. To simplify a rational expression, here is the fundamental principle of rational expressions. Here are your 2 steps for simplifying a rational expression. And here is an example to simplify 7x plus 35 over x squared plus 5x. You factor the numerator, so factoring out the greatest common factor, which is 7, times x plus 5. Factoring out the denominator, your greatest common factor is x, so you take out the x, times x plus 5. Your x plus 5 cancels, leaving your final answer as 7 over x. Here's another example. Here you factor x squared plus 3x minus 4, and these are the factors, x plus 4 times x minus 1. Factor the denominator, x squared minus x minus 20. The factors of that is x minus 5 times x plus 4. Your x plus 4 cancels, leaving your answer x minus 1 over x minus 5. Simplifying the following expression, 7 minus y over y minus 7. Here you factor out the -1 times the y minus 7. The 2 cancel, leaving your answer as -1. Section 2, multiplying and dividing rational expressions. Here's your 3 steps in how to multiply rational expressions. Again, the first step is always to factor completely the numerator and the denominator, and then use the rule above to multiply the numerators and the denominators, and the third step is to simplify your product. Here's an example. Multiplying monomials, 6x squared, 2 times 3 gives you the 6. X times x is x squared times 5 times x. And then the 10 can be broken down 2 times 5. And then x cubed times 2 times 2 times 3 again is broken down. Canceling the 2, canceling the 3, canceling the 2 x's, the 5 and the x, leaving your answer in simplest form, which is 1 over 4. Here's another example of multiplication. M minus n squared is equal to m minus n times m minus n times the m over the m plus n, and then m squared minus mn. Again, factoring this binomial, you take out the greatest common factor, which is m, times m minus n. M minus n cancels, the m's cancel, leaving your answer in simplest form, which is m minus n over m plus n. Dividing rational expressions. Here's an example. to divide a rational expression, you flip the second rational expression, and then you multiply. So here it shows you flip the second and multiply, and use the rules of multiplications. Again, the first step is to factor, and then simplify. Section 3, subtracting and adding rational expressions with common denominators. If the denominators are the same, you just combine the numerator. An example, 4p minus 3 over 2p plus 7 plus 3p plus 8 over 2p plus 7. The denominators are the same, so you just rewrite it and combine the numerator. 4p plus 3p is 7p, and the negative 3 plus 8 is positive 5 over the denominator. Subtracting the rational expressions, again the denominator is the same. Combining the numerator, you have 8y minus 16. You can factor that. The factor of that is 8, which is the greatest common factor, times y minus 2. Y minus 2 cancels from the denominator, leaving you an answer of 8. Again, same denominator, so here you can factor that polynomial into y plus 5, y minus 2. Combining the numerator leaves you 3y minus 6. Factoring 3y minus 6, the greatest common factor is 3, times y minus 2. Y minus 2 cancels, leaving your answer in simplest form, which is 3 over y plus 5. Now adding and subtracting rational expressions with unlike denominators. You first have to find the least common denominator. You factor each denominator completely. And then number 2, the least common denominator is the product of all unique factors, each raised to a power equal to the greatest number of times that the factor appears in any factor denominator. Here an example. Find the least common denominator of these two. The LCD would be 12y times y plus 3. Finding the least common denominator of this example would be x minus 3 or the 3 minus x. Here's an example. Rewrite the rational expression as an equivalent rational expression. So adding or subtracting rational expressions with unlike denominators. Here are the 4 steps. An example, add the following rational expressions. 15 over 7a plus 8 over 6a. Your least common denominator is the product of the two, which is 42a. So you have to multiply the first rational expression by the 6th. So you multiply the denominator by 6, the numerator by 6. And the second rational expression, you multiply the denominator by 7, the numerator by 7. So now your denominators are the same. Now you combine your numerator and writing your answer in simplest form. Another example, subtract the following rational expressions, 2x minus 6 and 6 minus 2x. Here's the answer to that one. And another example, again recall, negative 3 is negative 3 over 1. So your least common denominator is 2x minus 3. So you multiply the denominator and the numerator by the 2x minus 3, and then combining your numerator, leaving your final answer in simplest form.